Okay, we're about to finish our videos on surface area. This is surface area of pyramids and cones. So we have a pyramid drawn three-dimensionally and in the form of a net. And so this is the base of our pyramid, and you'll notice here we just have one base. And then this right here is going to be called a lateral edge. So it's like in this picture over here, it would be, I know I'm not putting, it's right there on the lateral edge. Now, let me change colors here. This arrow is pointing right here. And this is called, it's abbreviated with a lowercase cursive L, but this is the slant height. So that is not the lateral edge. So it's called slant height. Over here, that's this line right here. So that is called the slant height. And in our formula, it's abbreviated with the cursive lowercase l. And then we have the pyramid height itself. So the height of the pyramid is right here. It goes from the top right to the middle of the base here. And that is the actual height of the pyramid. And this is our vertex. And what's left is a lateral face. So the sides are called part of the lateral. So this would be a lateral face. And of course the base is also sometimes called a face. All right? So those are our 3D pictures and our net. And now let's solve a few problems. So here, find the height of a square pyramid with a base edge of 10 and a lateral edge of 13. So again, it's a square pyramid, so we know that all the sides are the same, and the base edges are 10. So the base edges are these edges here of the base. The lateral edge, remember that's this one right here, is 13. Now we know that when we draw the actual height, let me use a different color, the height here, it's right in the middle there, so if each edge is 10, that's going to make this 5. Okay, sorry for the break there. Let's see where we are. We want to find the height of the pyramid, and now what we can do is we can go back to this triangle, and again, half of 10 is 5, so we have a 5 here and here, and we can do Pythagorean theorem to find this right here, and that's going to be 12. So again, we have a right triangle, and this is 12, and this is 5, and so this is going to be the height of the actual pyramid. So that is 5 squared plus b squared is equal to 12 squared. Okay, and so we'll get 25 plus b squared is equal to 144. We can subtract 144 from, or excuse me, 25 from 144. This is not a triple. And we get 119. So we can say that b squared is equal to 119 and b is equal to the square root of 119. That's a fine answer, or if you would like to give me a decimal, it would be 10.9. Okay, so we have two different triangles that we can find inside that pyramid. Now here are formulas for lateral surface area and total surface area. Lateral is 1/2 capital PL. Capital P we already know to be the perimeter of the base. L is the slant height. Okay, and so remember from this picture, this is your slant height right here. It's not the edge. Then the total formula is 1/2 PL plus a capital B. And remember, a capital B is area of whatever the base is. Okay? So let's look at a few more examples. Here we have a square pyramid. So the sides of the square are 10. And so these are 10. And so this triangle right here this is going to be 5, as well as this over here is 5 in those two triangles. what we're looking for is 1/2 PL. Okay, change my colors a little bit. So L is right here, and we have a 5, and we have a 13 given here for this. So let me draw that here. So if you do Pythagorean theorem here, you're going to get the height is 12. I don't know that we even need that actually, because we just need 1/2 the perimeter of the base. The sides are 10, so the perimeter would be 40. So this is 1/2 times 40 times the slant height, which is 13. So actually in this case we don't really need the height. We're going to need that next when it comes to volume. So this is just 20 times 13 is 260. Okay, then the area of the base is 10 times 10, or 100. So this is 260 plus 100, or 360. All right, I'm going to slide up, and you should pause and try and do the quick check yourself. Okay, in this problem here, the perimeter of the base, each side is 12. There's 4 of them, so that's 48. And then when we have 1/2, 48, and now we need L, the slant height. Well, the slant height is right here, and they give us the other 2 dimensions of the triangle are 6 and 8, so hopefully you recognize by now that that would be 10. So 1/2 48 times 10 is 240. And then to that, we're going to add the area of the base, and each side is 12. 12 times 12 is 144. And so 240 plus 144 is 384. Okay, the next picture that they give us, well, they don't give us a picture, and it's a little hard for me to draw that picture. So what I usually do is a triangular pyramid, so I know the base is a triangle. So that's really what I need to be looking at, is the base. And then it's going to have a slant height of 20 and a base edge of 24. Okay, so a regular triangle means all the sides are the same, and if the base edges are 24, these are all 24, and so the perimeter of the base is simply 24 times 3, which is 72. Now this is 1/2 PL, or the slant height, and they give us that the slant height is 20. So this is 1/2 times 72 times 20, or 720. And so this is 720 plus the area of the base. So now the area of the base is a triangle, and it's an equilateral triangle. So if I draw the height, it cuts this in 2, and hopefully you'll recognize that this has got to be a 30, 60, 90 triangle, and I have x and 2x, so this would be x to the square root of 3. So this is 1/2, well actually let's do it the other way, that's another way to do it. The base is 24 times the height, which is 12 to the square root of 3, divided by 2. Base times height divided by 2. 144 times the square root of 3. You could have done that with 1/2 AP as well, but it's probably easier this way. All right, so there is one more quick check. So why don't you try and pause the video? Maybe I'll leave that part up there for a moment and see if you can't figure out how to do the last one. Okay, let me erase now. Okay, this is going to be a triangular. Sorry. So I'm going to draw my triangle here. Okay, it has base edges of 18. So the perimeter is 18 times 3, and that's 54. And this is 1/2 PL, and they give us L, the slant height is 24, so 1/2 times 54 times 24. and that is 648. So to that, we're going to add the area of the base, and the base of this triangle is 18, and if we draw our height, it's going to cut that in two, and this is going to be 9 to the square root of 3. So the base of the triangle is 18 times 9 to the square root of 3 divided by 2. So it's 81 to the square root of 3. And so this is simply 648 plus 81 to the square root of 3. And that's your final answer. Okay, now we're also going to look at cones. So these are slightly different, just a different formula. In the cone, this is actually the lateral edge. We don't have a slant height, but this would be the lateral edge. Then we have a radius on the base of the circle. Then we have the height of the cone. We have the vertex at the top of the cone. We have the center of the circle. And then we have a radius here seen in the three-dimensional picture. So those are the things that we're going to need in our formulas. So when we look down here at the definitions of the lateral edges say that we have the curved surface of the solid. It looks curved, and it's actually, when you look at the net, it's like part of a circle. The total area then is going to be the total surface area of a cone will be the curved surface and the base, which is in the shape of a circle. Okay, so here are our formulas. Pi RL for lateral. Here the L is talking about the lateral on the cone itself. We don't have a slant height. And then pi RL plus pi R squared, because the base is a circle. So in our first example here, again, the formulas, let's write pi RL and pi RL plus a capital B. So pi, the radius here, we're going to have to use Pythagorean theorem to find. I'll call this 45 squared plus b squared is equal to 51 squared. And to try and not have to make two videos, I'll do this as quick as I can. And that is equal to 24. So we have pi times 24 times 51. And this is 1224 pi. And then to that we add the area of the base, and the base is a circle, pi R squared. So pi times 24 squared, and that is 576 pi. These are like terms, so we can add 1224 pi plus 576 pi, and we get 1800 pi. So I kind of ran out of room. But the total surface area is 1800 pi. All right, let's do the one below it. In fact, I'm going to pause it so that you can try and do it. Okay, on this next problem here, I've drawn the picture where we have the radius is 6 and the height is 21. If you do Pythagorean theorem here, I know it asks for your exact answer, but you get this really strange answer right here. So it is perfectly fine to go ahead and just round that off to 21.8. And so pi times 6 times 21.8 is 131 pi. And then our total, when we add the area of the base, comes out to 167 pi. I did put the exact answer with the radical if you want to see it. We're almost out of time, so I'm going to pause again for the last one and then put the answer up. Okay, the radius of a cone is 5. The radius of the cone is 12, so I drew this as 12, and the height is 5. So if you do Pythagorean theorem, you find 13 over here is the is L, or in this case,